large esophagus, with a normal squamous body of the esophagus is replaced with specialized intestinal. This can then progress on through to lower extremities and lead ultimately to invasive carcinoma. A number of factors can influence this progression, including physiological factors such as the reflux of acid and bile from stimulating to the esophagus, environmental factors such as obesity, and genetic and molecular factors such as p53 mutations and NF reactivation. As illustrated in this graph, the incidence of esophageal adenocarcinoma increased by almost 50% in recent years, and this is a trend that is mirrored across developed countries. Whilst the genetic and molecular factors which can influence cancer progression have remained relatively constant, the incidence of obesity has also increased sharply in this time frame. And this is why much research into investigating the possible associations between obesity and esophageal adenocarcinoma. And work carried out in our group that identified high prevalence of obesity and metabolic syndrome in patients with Barrett's esophagus and esophageal adenocarcinoma. There are a number of mechanisms by which obesity may increase the risk of esophageal cancer. From a mechanical point of view, increased intra-abdominal pressure can lead to increased reflux and increased cancer risk. Adipose tissue is now recognized as more than simply an disorder, but as a highly metabolically active endocrine organ. It secretes a number of adipokines, pro-inflammatory cytokines, growth factors, and hormones, and there's been much research into its possible effects on cancer progression. In esophageal carcinoma, one growth factor of particular interest is the insulin-like growth factor 1. Insulin-like growth factor 1 system consists of two ligands, IGF-1 and IGF-2, three receptors, IGF-1 receptor, IGF-2 receptor, and insulin receptor, and 6 binding proteins, IGF-BP136. As illustrated in this diagram, binding of the ligand to the IGF-1 receptor activates a number of pathways, which leads to cell proliferation and inhibition of apoptosis. A dysregulation of this pathway can give rise to malignancy, hence the rationale for investigating further the role of this in esophageal cancer. So the first aim of this research was to examine the expression of the IGF-1 receptor in response to IGF-1 in a panel of esophageal cancer cell lines. Secondly, to examine circulating levels of IGF-1 in a cohort of patients with esophageal cancer. And thirdly, to examine IGF-1 receptor expression in matched esophageal tumor sections from the same patients. RT-PCR and Western analysis was used to determine the IGF-1 receptor expression in the esophageal cancer cell lines. And TTSA was used to determine changes in cell viability in response to exogenous IGF-1. In patient samples, serum levels of IGF-1 were measured using ELISA, and immunohistochemistry assessed the IGF-1 receptor expression in the full breast tumor sections. So looking at the results, the RT-PCR results showed that all 4 of the cell lines expressed mRNA for the IGF-1 receptor. However, at the protein level, there was visibly higher expression in the squamous cell lines. The cell lines were then treated with various concentrations of exogenous IGF-1, and changes in the cell viability were assessed by TTSA. There was no change in viability in the squamous cell lines. However, in the adenocarcinoma cell lines, there was increase in cell viability, increasing IGF-1 dose, most notably in O303. We then progressed on to our patient samples and worked with an unselected cohort of 50 patients who were subject to our centre between 2006 and 2009. The cohort consisted of 36 males, 14 females, 39 adenocarcinomas, 11 squamous cell carcinomas. Obesity was assessed using 3 independent measures of BMI, waist circumference, and visceral fat area. So first we looked at the circulating IGF-1 levels using ELISA. There was no association between circulating IGF-1 and sex or obesity status. But we did observe higher circulating levels of IGF-1 in those patients with adenocarcinoma compared to those with squamous cell carcinoma. In the same cohort of patients using their matched tumor sections, we looked at the IGF-1 receptor expression using immunohistochemistry. The staining was scored by 3 independent observers. Firstly, the intensity of staining was given a score between 0 and 3. Representative images are shown here. And then the percentage of cells staining positive was given a grade between 0 and 100%, giving an overall score between 0 and 300 for each section. We looked at the 2-year survival in those patients that had IGF-1 receptor expression above and below the median. We saw an 18% reduced level of survival in those patients with IGF-1 receptor expression above the median compared to those with levels below the median, although this did not reach statistical place. There was no difference in IGF-1 receptor expression between the adenocarcinoma sections and the squamous cell carcinoma sections. However, interestingly, in the adenocarcinoma sections, we observed a wide variation in staining intensity as the tissue moved from high-grade dysplasia through to the invasive edge, with the highest levels of staining observed in this invasive edge region. When we analysed this further, we found that in the adenocarcinoma sections, the IGF-1 receptor expression increased statistically significantly as the tissue moved from normal tissue through to high-grade dysplasia, through to adenocarcinoma, or through to the invasive edge. So to summarise, we saw higher IGF-1 receptor expression in squamous cell lines, but only adenocarcinoma cell lines responded to exogenous IGF-1. Also, there was significantly higher circulating levels of IGF-1 in patients with adenocarcinoma, suggesting an important role for IGF-1 in adenocarcinoma growth. Significantly increased IGF-1 receptor expression was observed in the adenocarcinoma sections including high-grade dysplasia, tertiary invasive, again suggesting that in adenocarcinoma, the IGF system is utilized overall. So to conclude, the IGF-1 system is preferentially upregulated in the invasive edge of esophageal adenocarcinoma, and may be potential therapy targeting this cancer subtype. And currently, a much larger study using a 200-patient cohort is underway, which will examine further the role of this IGF system in esophageal cancer, and could provide information on overall disease-free survival.
Thank you very much. Yeah, please.
Have you looked at any of the downstream targets of the IGF-1 receptor, such as PKB6 with increased activation in the adenocarcinoma?
Yeah, Darren.
IGF-1 is free, it's an annual ban, BP3. So did you try and make a little video with IGF-1 and BP3 to see whether or not that's real? And in the cases of some of the cancers where you decide.
Yeah, that's an interesting point. We only looked at the free circuit levels of IGF-1 in patients, and we didn't look at the final process. Something in the
Yeah, please.
Did you look at the relationship between IGF-1 levels and cardiovascular status? You expect to see some difference.
Yeah, that's an interesting point as well. We didn't look at this part of this study, but we do have information on metabolic syndrome status on these patients, so it's definitely something we can look at to see if there any association between the cardiovascular status and the IGF-1 levels.
Are any of the new multiple drugs that are available potentially have effects on IGF-1? All the targeted therapy, huge industry out there, every company has their own channel. Is there anything like, any suggestion you might affect IGF-1?
Okay, fine. Did you finish? Yes?
Brilliant. Until you said brilliant.
Okay, fine.